Hello everybody. Today I will give you a quick demonstration and a tutorial on how you can decrypt SRTP using rtpengine. Before you get too excited, obviously you have to know the keys that were used to encrypt the SRTP, so there's no cracking of encrypted audio or anything going on here. Now, there are dedicated tools to doing this. Tools you can find online that operate on a PCAP file directly and decrypt the SRTP in the PCAP file. But those tools might not be readily available, or they might not support all cipher suits. In particular, in this example, we're using the relatively new AEAD cipher, which does not have very good support in third-party tools, but rtpengine supports it, and that's why we're using rtpengine to decrypt the SRTP. I have been given a PCAP file that captured a bidirectional RTP flow, SRTP flow. Now Wireshark in this case does not know that this is SRTP because there's no SIP traffic in this PCAP, but you can tell from both the packet size and from the contents that this is actually encrypted. Yeah, just to explain, we will be using the SDS key from this SDP here that was captured in the log file. You can do the same thing with DTLS SRTP. You still need to know the crypto key, of course. Now, if this was going through rtpengine and the debugging was enabled, it would output log lines like this and actually print the crypto keys that were coming out of the DTLS. The only thing here is that key and salt are given separately in the log lines, and so in order to use them, you would have to concatenate them. So the first thing I need to do is I need to filter this PCAP file so that I get a new PCAP that only includes the RTP flow that I actually want to decrypt. And in this case, I'm going to use the traffic coming from this call participant. So I'm interested in this source port here. So I'm going to use a Wireshark filter here. And now this shows me only the packets I'm interested in. And I can save this. I say export, and I can say only export the packets that are displayed. And I'm going to call this filtered, overwrite it. And now I have a PCAP file that only includes the packets I actually want to see and I want to decrypt. Now what I'm going to do is I'm going to transfer this to a separate machine. I'm doing this because I tried doing this over a local host in the past, and this did not quite work right. There might be ways to do it locally too, or there might be some workarounds, but I don't know. If anybody knows, please let me know. So I transfer this to a different machine, and the next thing I will need to do is I need to rewrite this PCAP because I will be using TCP replay to send the packets into a running rtpengine. And what TCP replay does is it just takes the contents of the PCAP as is and puts it on the network. I obviously don't want to use any of those IP addresses. I want to use my own IP addresses. And so I'm using tcpRewrite to rewrite the PCAP file. And the syntax, it's a bit awkward, but I'll put the command line in the video description. Essentially, you have IP address pairs, and this is the source address from the PCAP. And then this will be replaced with the source address of where I'm sending from. And this is the destination address from the PCAP, and this will be replaced with the destination address where I'm actually running rtpengine on. You also need to give it the MAC addresses. This is the MAC address of the destination machine where RTP engine is running. Then this is my own local address where I'm sending from. Then you need to give it the C flag. This tells tcpRewrite to fix the checksums, because without that the packets would not be accepted. And then simply input output file. Another option here to make it write the file in regular Ethernet format and not something different, because this is generally the only thing that works. And finally, the destination port where I'll be sending to. So originally in the PCAP we have this port here, and I want to replace this with some other port. Now, which other port that is depends on what's coming out of RTP engine, and we'll see that in a moment. Then what else do I have? I have 2 dummy SDPs that I will use to talk to RTP engine. Both of those are my own local address here. And one has port 7000, one has port 9000. That doesn't really matter. But what I will do is my offer SDP I will convert to an SRTP SDP, and I will use the crypto key from the SDP, from the log file. So I will be using the same crypto key as was used when this PCAP was captured, which was used to encrypt the SRTP. And that's all I really need for now. Then I will start my RTP engine here. I'm running it locally on my own machine. It's not necessary to run it locally. You can run it on a VM, you can run it on a different machine. You just need to make sure the addresses and everything are matching up. So this is running here now. No special options given, just a regular instance of RTP engine running. And then I will do an offer answer exchange. I will be using just a random call ID. Doesn't really matter what you use there. If you have RTP engine installed from packages, then this ng-client script will be available in your path as any other command, and you don't have to do this Perl magic here. So I will doing an offer, give it my random call ID. From tag foo, it doesn't matter what you use there. And then I tell it to use the fake dummy SDP that I have prepared here. From the offer, this will be the SRTP offer. And then I tell it to translate this to plaintext RTP. And this is the important part. So I'm doing this, SRTP goes in, regular RTP comes out, as you see here. And then I'm just gonna answer back. Nothing special here, same random call ID as before, from tag foo to tag bar. Now I gotta give it some kind of to tag, right? And then sdp-answer. And as soon as I give it the answer, I'm ready to play the SRTP in, and what will happen is that plain RTP will be sent to this address and this port here. And I want to capture this, so I have my Wireshark here, another instance of Wireshark. I will capture traffic going to destination port 9000. That's the one I have in the SDP here. So I'm gonna start this off. And then the last thing I have to do, I give the answer. And this now RTP engine gives me the destination port where I have to send the SRTP to. And this is what I will use in the tcpRewrite command. Now I'm rewriting it, and now I am ready to replay the PCAP. This is TCP replay. It's pretty simple. You tell it the network device you want to send it to, and then optionally, if you want to speed things up because normally it plays it back in real time. You can tell it to play it faster. And off we go. And as you can see, RTP is coming in. And if you look in the Wireshark, RTP is coming out. And in this case, you can see it down here. This is plaintext RTP. This is decrypted. And then if you want, you can use the regular Wireshark tools to analyze the RTP. You can play it back, save it to WAV file, or whatever else you want to do. And that's it. That's how you decrypt SRTP with RTP Engine.